Are we ready to rumble? Oh, we are live. I guess that means I should start the show. There we go. This is TWIS. This Week in Science, episode number 619, recorded on Wednesday, May 17th, 2017. Timing is everything. Hey everyone, I am Dr. Kiki, and tonight on This Week in Science, we are going to fill your heads with history, origins, and randomness. But first,
disclaimer, disclaimer, disclaimer. Intelligence is the one thing we depend on in modern society more than any other. With it, we are healthier, more prosperous, more secure, and more free. Without it, we will be sicker, poor, at greater risk, and beholden to others. And of all the intelligence out there, the most important, the most precious, the most pluripotent with potentiality is that which was not known before. Hidden knowledge that, once revealed by science, can make up for prior lack of intelligence about an issue and propel us along a path unseen to us previously. Following our programming contains such previously unknown intelligence that, if shared with the adversaries of the United States of America, could lead to greater dialogue on important issues that affect all mankind, issues that put into perspective tensions over trade and territory minutiae, issues like global warming, disease prevention, sustainability, our common origins, like how half a dozen hominins were walking the earth at the same time, and have you seen the billions of galaxies that the Hubble has brought into view? So, if you find yourself in casual conversation behind closed doors with potential adversaries and wish to tout the intelligence that you are privy to, look no further than This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
and good science to you, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back again. We're back again, and we have so much wonderful science ahead. And, you know, maybe people want to take a break from the craziness of the world and be surprised by the smoothness of science. So smooth. On June 10th and 11th, I want to remind everyone that we will be in Philadelphia at the Greater Philadelphia Expo Hall for the Young Innovators Fair. And you can find information on that at younginnovatorsfair.com. And I've got tons of science news. All right. What did I bring today? I brought stories about quantum teleportation, because that's always a little weird. I've got stories about randomness, but not so that you can be random. Maybe so that other people can be random. Random is good. And also, trees are on the move. Trees. Yeah.
Is that like in that book, what are they called? The Ents?
The Ents. Right. Like the
They're on
Ents.
the move?
They're on the move. That's right. That's right. That's what
That
we're
one
digging
book,
into.
what was it called? What was it called? What was it called?
Well, there was The Hobbit and the Lord of
Something
the
about
Rings.
jewelry. Ah, that's what it
The
was.
Lord of the Rings.
Yes, yes.
Yes. Absolutely. Justin, what did you bring today?
I brought the origin of life, microbes regulating your genes, an atheistic survey, and bumblebees taking over Detroit.
What?
That's a good thing, I think.
Yeah.
I want to hear the buzz on that one.
Ooh.
Oh, Blair, what's in the animal corner?
Oh, I brought 3 different kinds of animal parents. Right in between Mother's Day and Father's Day, thought we'd explore some of those new findings in what it is to be a parent in the animal kingdom.
It's hard. That's just all there is to it. No matter what, it's hard.
Yes, we'll explore different ways that it is difficult tonight.
All right, we've got a great show ahead. And as we get started, I would like to start with our new segment for the show. What has science done for me lately? Minion Julian Sammy wrote in to say, at the end of July 2015, I checked myself into a hospital because I couldn't breathe. 5 days later, after an emergency tracheostomy, the diagnosis of laryngeal cancer was confirmed. I call August 17th the day of the short knives, when 2 highly skilled professionals cut my throat. After the total laryngectomy, the anatomy of my neck has been drastically reconstructed. So, what has science done for me lately? Well, let's see. I breathe through a hole in my neck between my collarbones, but I'm still breathing. I count that as a win. Be well.
That is a win. Absolutely.
Be well, Julian. Thank you for writing in to let us know what science has done for you lately. And anyone out there, everyone, please send me your thoughts on what has science done for you lately. I want to know. I want a different answer every week of this year from our minions. So that means you guys need to email me. My email address, Kirsten, Kirsten, at thisweekinscience.com. Okay, diving into the big stories. I've got some really fun stories here. So we know we're affecting the earth, right? There's all these humans all over the planet. We're building buildings. We're doing agriculture. We're, I don't know, eating all the fish. So long and thanks for all the fish. You know what we're also affecting? Radiation that's coming into the planet. Yeah. Yeah, this is a very, very interesting study coming out of NASA Goddard Space Flight Center. Researchers just published in Space Science Reviews. There's a comprehensive paper on human-induced space weather. Now, I want to say that again. Human-induced space weather. Not humans are changing the climate on Earth, but we're changing space weather.
Oh, no.
We're changing space weather too. Like our influence is starting to leave the planet. And one example of this is that we have created something of a radiation bubble around the planet. And it's gotten stronger as we have developed our radio frequency transmissions. Now, this bubble that has been discovered by these researchers, it is made up of very low frequency, or VLF, radio communications. And these kinds of communications are very low frequencies, so they're the kind of frequencies that are used to communicate with submarines. So say things sending signals through the ground, underwater, to be able to kind of get into stuff. And so this is the kind of technology that we use to communicate with our submarines. And as we have, tried to be stealthy, our communications, we got more communications and different communications. And these communications don't just stay in the ground. We're transmitting them all over the place. And they are getting stronger. They've gotten stronger since like the 1960s, stronger and stronger. And what researchers have discovered using probes in our atmosphere, they have discovered that the outward edge of this VLF bubble, as it's expanding outward from our planet, corresponds almost exactly to the inner edge of the Van Allen radiation belts. And these are charged particles that exist around our planet in these belts, and they're held there by Earth's magnetic fields. But researchers who were involved in this think that maybe these Van Allen belts might have come in closer to Earth in the time before we were shooting out all of our very low frequency signals. And that what has happened is that our very low frequency transmissions have pushed the Van Allen radiation belts a little bit further away. And that the normal place they would sit around our planet as based on our magnetic field would actually be closer to us. And so these very low, what's going on here? How is this happening? These very low frequency transmissions are actually, these are little particles boop, 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 that interact with radiation particles. And so what they're finding is that we've got signals and stuff that are actually interacting with the radiation that's coming in toward the planet. And in another part of this study that was fascinating, some data from the Cold War high altitude nuclear tests became available. And they were able to determine that they were to use this data to actually see how these radiation mechanisms, so like high altitude nuke blows up, lots of radiation given off, how does that perturb the magnetic field of the Earth? And how does it hinder the magnetic field from protecting the Earth? And then what their big question that they're looking at is, how can we learn from this data, from our transmissions, from our nuclear tests in the atmosphere, maybe how to protect satellites and astronauts from space radiation and space weather? Yeah. Is there stuff we can do to actually make our bubble bigger? Can we artificially increase the size of our protective shield?
Yeah, and I think this leads directly to putting submarines in space too.
Haven't we already done that?
Those are called Space Marines, Justin. Geez, you're already doing that.
Space Marines.
This
Yes,
is
the
like
International Space Marine Station. Yes.
Yeah.
back in the 40s, what have you, whenever they looked at the future, like they would do the radio plays or even some early film, when they would put mankind into the future exploring space, they would basically put the spacecraft was basically a submarine. That's how they sort of imagined it would have to be. And even like it would like be pinging space, like boop, boop, like they would have space sonar. And, yeah.
What are you saying? That's not what we're doing?
That's exactly what we're doing, Blair.
Okay, great. Because they're like those tin, like tubular.
Totally tubular, man. So anyway, humans are creating our own little protective-y, bubbly blanket that is changing space weather. And one fun thing that I didn't know about, there was one of these high altitude nuclear tests, which took place on my birthday, August 1st, but a few decades before I was born, 1958. This teak test was conducted over Johnston Island in the Pacific Ocean. And on that same day, the Apia Observatory in Western Samoa observed an unusual aurora. And so this is in the Pacific Ocean. Over the Pacific Ocean, they observed an aurora, which is only usually observed at the poles, the North and South poles, where the magnetic field is really strong, and they've got the cosmic rays and particles coming in from outside and interacting, these electron interactions with the atmosphere. So they think the energetic particles released by this test followed the Earth's magnetic field lines to Samoa and induced the aurora. And so it's kind of interesting that the radiation and the energy that was created from this nuclear explosion in the atmosphere, that energy would actually kind of tune in with the natural energetic pathways in our atmosphere to create other energetic events elsewhere. Interesting. Over Polynesia, yes. So there's interesting stuff to be learned as data becomes unclassified from these old school nuke tests during the Cold War. Now we talk about communications, right? And you want to keep our communications secret, right?
Mm-hmm.
want to have special communications. Well, quantum communications, quantum teleportation is potentially one of these ways that we could do that. And researchers in China, for the very first time, have achieved something that I don't understand. No. It's called direct counterfactual quantum communication. And
that's easy.
that.
Yeah.
Yeah.
So it's where magic
Nope.
happens because of
That's-
physics.
That's pretty
And
much-
Harry Potter becomes like a reality.
Right.
that is basically
think.
what I'm going to say, but in different words. So this is a different quantum teleportation than we've talked about on the show previously. In
Not your
previous,
grandfather's quantum teleportation. No, this is new and improved.
this is newfangled quantum teleportation. So quantum teleportation we've talked about before is the result of quantum entanglement. And you have to have two particles. Usually they're together and they're entangled when they're close together. And then you can take one of those entangled particles however far away you want. And because they're entangled, if you change something about one of the particles, then that same aspect will change on the particle that's very far away. And thus you have information transfer over large distances that's instantaneous. But the problem is you've still got to take these particles from one place to the other. And so you're still transporting particles between locations to get them to these places. So researchers are trying to figure out how they could set up a system that doesn't involve actually transporting particles. And they say they've done it. And they've, instead of using entanglement, used a phenomenon that's known as the quantum Zeno effect. And the quantum Zeno effect is this strange thing with quantum systems. You know, there's the Schrodinger's cat experiment where it's like you don't know what's going on inside of the box, but then you open the box and suddenly you know what's happened, right? So basically you are determining the state of particles in a box, right? You're determining the state of particles in your experiment. And so in a quantum Zeno effect situation, you have an unstable quantum system. So it's potentially anything. It's not stable. It's doing whatever it is in your box, right? There's all sorts of stuff happening in this box. You have no idea what's happening in the box. But what you do is you get something in there to repeatedly measure it over and over and over very quickly. So it doesn't know what's going on. And so these unstable particles never actually decay. And so it's kind of like it's like you've got a pot of water. This is the anecdote that people use to explain this, that it's like having a pot of water. You know how there's the idiom, a watched pot never boils?
Mm-hmm.
That's what this is. This is the quantum Zeno pot that never boils because it's being watched, right? It's just being watched, so it can't do anything. It can't change its crazy unstable state, and it's like a frozen boiling pot of high probability. So anyway, they've taken this quantum Zeno effect and they have transferred a quantum state from one site to another using this effect without any quantum or particle being transmitted between them, using photons, because we know that what can photons be?
A particle or a wave.
A wave, man, right. A particle or a wave. And so if you put them in the quantum system, they will be waves. They are not particles in a unstable quantum state. So they set up a system where they had a few different options for what the light would do. They had 0 for white and 1 for black, and then they had an inconclusive result that would get rid of stuff. And basically using a set of 0s and 1s and photons passing through a series of interferometers, they were able to transmit a GIF or a GIF, depending on which way you like to pronounce the word. But, you know, one of those little moving pictures that we all like to send each other over Facebook Messenger on the internet. They sent a black and white image from one place to the other, but never actually sent any particles to transmit that image.
Abracadabra, poof.
Poof! Magic. Quantum magic. Yeah. And so it needs to be verified by external researchers still at this point, but this is a definite possibility for the next step in quantum teleportation. This paper was published in the Proceedings of the National Academy of Sciences, in case you are interested in checking it out yourself.
I don't know. This is crazy.
Right?
It still kind of sounds like
I
magic.
get it.
No, there are
Also, Kiki, the one part of this I don't understand is that a watched pot does boil.
Not if you have ADD. If you have ADD, it never boils when you watch it. It just takes too long.
Sheer stubbornness has resulted in me watching a pot boil several times.
It's an idiom.
You lead an exciting.
It's an idiom. It's not actually truth. What watch pots in reality do boil, but in a quantum world, never. They never do.
Oh boy.
This is This Week in Science. I hope we just
What's also wild?
you.
In the quantum world, if you watch a pot less, it does boil quicker.
It's true.
That's
what we just learned. Exactly. It becomes a little more stable. It does what it wants to do.
boils faster if you don't look at it.
Justin, I'm looking at you.
A lot of questions these days about where we are going as a planet. But before we even get there, we still haven't answered how we got here in the first place, in the early beginnings of life on Earth. How did this whole thing get started anyway? Religions often have creation myths that seem to simplify the process. Abracadabra, poof, and life is abundant. But the real story is much more complicated. But it doesn't prevent scientists who study the origin of life from using a little abracadabra poof of their own. This is University of Illinois' Gustavo Cestano Anoles, professor of the Department of Crop Sciences. He explains all living organisms have a metabolism, a set of life-sustaining chemical transformations that provide the energy and matter needed for the functions of the cell. These metabolic transformations are assumed to have occurred very early in the primitive life of the Earth. Organisms probably replaced chemical reactions already going on in the planet and internalized them into cells through development of enzymatic activities. Gustavo's study looked at 249 genomes of different organisms in a searchable database known as the Gene Ontology Database, the GO, which not only allows the genes to be sort of searched through and similarities, but actually has descriptions within it about what those gene functions are. So, quotey voice of Gustavo again, you can take an entire genome that represents an organism, like the human genome, and visualize it through the collection of functionalities of its genes. The study of these functionomes tells us what genes do instead of focusing on their names and locations. For example, we can find out what kinds of catalytic recognition or binding activities a gene product has, which is much more intuitive. The best way to understand an organism is through its functions. So they looked at the number of times functions appeared in the genome, right? Certain functions where it's got this information on how to do this thing more than one place. The idea was that older gene functions, such as the catalytic activity of metabolism, would likely be shared by all organisms, right? We all need to have a metabolism to be alive, and would be found also in large numbers. While more recent gene functions are going to be found in lower numbers and smaller subsets of organisms. They made a frequency tree that trace the most likely evolutionary path of molecular functions through time. The base of the tree, there's things that we all have in common. These are going to be the ancient functions, right? In the top, they're those branches that are going up near the top, reaching out. These are going to be the more recent add-ons to the gene functions. They found near the base of this tree of functions, the functions related to metabolism and binding. Quoted voice again, it's logical that these functions started very early because molecules first needed to generate energy through metabolism and had to interact with other molecules through binding, says Gustavo. The next major advancements in this were functions that made rise to macromolecules, which is where RNA may have entered the picture. Very important. This is higher up, and RNA is now entering this picture. Next came the machinery that integrated molecules into cells, followed by the rise of functions allowing communication between cells and their environment. And finally, going up, you start to see functions related to highly sophisticated processes. What's a highly sophisticated process? Things like muscle, skin, a nervous system. These are kind of further out. These aren't nearly as ancient-y. The findings are running contrary to the sort of popular ideas of RNA as a first step of life, but rather a metabolism-first origin of all life on the planet. Aside from shedding light on the past, following the progression of these molecular functions through time might even predict where life on Earth is headed. People think of evolution as looking backwards, Gustavo says, but we could use our chronologies and methodologies to ask what novel molecular functions will be generated in the future. Pretty cool, and very sort of make sensity sort of way of looking at it. Look at a whole bunch of life forms, see what gene functions they have in common, and those most likely are the oldest.
Right. Trace it backwards. Just go take it backwards and be like, all right, where did we start? How did organisms mutate out of that? And it really does. I mean, more and more studies keep coming out suggesting that this metabolism first, RNA first, yes, but even before that, it's just this kind of chemical processes. Metabolism first, that maybe there were these pseudo cells that were in the muck and the mud, just in the mud, these little pseudo cells that were doing things, what they doing in there. And maybe that's then RNA came in, because then maybe they're communicating with each other. Then, maybe that's how it all got going. And this is a neat way to be looking at that, though, to take it from the genetic standpoint. Yeah. And then at the end, like you said, taking it to the future, there is the big question of where is everything going to go? People still ask the question, are humans still evolving? What's going to happen next? What would change? Why would it change? And this is an interesting way to start looking at that.
Yeah.
Interesting perspective.
Or as I kept thinking on this, it's also a way of looking at how diseases might evolve going forward too. Where are these further out branches away from our origin going to put us in more jeopardy to the environment that we encounter now? So it's an interesting tool. It's going to be, I can't wait to see how the reaction of those studying the early origins of life react to this if we start because the RNA thing is very popular right now. So I'd like to see this sort of argument of ideas unfold a bit more.
Yeah, I love your idea too of looking at diseases, or even if we're going to talk about kind of like we want to talk about viruses, maybe, or maybe want to talk about the development of antibiotics. So how do parasites, how do bacteria, how do viruses take advantage of our cellular machinery? How do they gain access to our cells and cause disease? And what genes are they taking advantage of? What genes are they using? What we use this phylogenetic method to figure out our Achilles heel?
Oh, I've got a story like that in the second half.
Well, that's a great segue. Moving on up to not the second half yet. Right now, you know what time it is?
What time is it?
It's time for Blair's Animal Corner. If I can get there.
She loves our creatures, great and small. Biped, millipede, no pet at all. Wanna hear about animals? She's your girl. Except for giant pandas and squirrels. Animal Corner.
What you got, Blair?
I'm starting off with a story of a great dad. Justin, do you think you're a great dad?
No. I'm all right. I'm not bad.
Well, let me ask you this.
Great.
How many times a day do you nip at your offspring to remove debris?
Oh, constantly. It's like
How many times a day do you fan them with oxygen-rich water?
no more than once.
Oh, okay. So if you were an anemonefish, you'd probably be an okay dad, but not great. Anemonefish dads do a lot of parental care, particularly of the eggs when the eggs are growing. They are constantly nipping at them to remove debris, and they are constantly fanning them with oxygen-rich waters. They will do this with their own eggs, or even if they lose their eggs, but there are some stranger eggs from an unrelated nest that are that replace theirs or are nearby and they are not being cared for, they will care for those as well. That's what such good dads they are. Recent research specifically was looking at why. What makes them such good dads when so many dads in the animal kingdom don't care for their offspring at all. So, University of Illinois student Ross DeAngelis and his psychology professor Justin Rhodes were looking at what do you think might control behavior, parental behavior? What do you think? What is it always? It's hormones. It's always hormones. So they were looking at hormones.
I was gonna say I was gonna say like annoyance level.
Yeah, those eggs just won't stop crying.
I don't know.
So they were looking at isotocin, which is analogous to oxytocin in us, which is the hormone, the love hormone, the hug hormone, the mother hormone. These hormones that we already identify as being directly linked to parental care in mammals. So isotocin is the analogous hormone in fish. And they found exactly what they expected. When they blocked isotocin from the fathers, they stopped taking care of stuff. Yeah. So it was pretty much directly related. Without that isotocin, they stopped tending to their young. They kept drifting away. They weren't even really protecting it.
Like, I don't really care.
Yeah, I have no feelings for these unknown eggs. The next thing they looked at was arginine vasotocin. So arginine vasotocin. The analogous hormone in humans is arginine vasopressin, and this hormone also they suggested potentially had some influences on parental care. They blocked the vasotocin, and they had less aggression than untreated counterparts, but they also became even more attentive to their offspring.
Huh.
Yeah. So blocking the vasotocin made them better fathers. Why is that? Well, the hypothesis is that it's actually reducing aggression and thereby reducing vigilance in nest defense, which means they just have the blinders on. They're just nip, 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 fan, 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 nip, 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 fan, 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 not paying attention to other animals, anemone fish, anything in the area. So that's the current hypothesis. But really what we know from this is that these two different hormones are both affecting parental care directly in these anemone fish. So you could see that potentially there's lots of parallels that could be drawn from here. Right. So, and they've already done a lot of there's been a lot of experiments on aggression and hormones related to aggression. There've been a lot of experiments on oxytocin in parental care, but mostly it's been on females. So this is kind of an unusual combination of these common elements in an experiment. So it opens a lot of other questions. I do think it's important to mention, though, even though it wasn't mentioned in the article anywhere, that anemone fish are sequential hermaphrodites. So they all of them start as males.
As males.
And the dominant individual, the larger individual in a mating pair is the female. When the female dies, the male transitions into a female and finds a male to mate with. So also now we have the animal giving the most parental care as the beta, as it were, as the non-dominant individual. So is that related? And are hormones related to that?
Hormones absolutely have to be related. I mean,
right.
if we're talking
they're related
about
to the transition, yeah, for sure.
If they're related to the transition, they're going to be related to the parental care.
So it raises many extra questions that are not answered in this article. So I think that also that's a whole extra element to be looked at, is that if we pick, for example, meerkats, a female dominant society, will you see oxytocin mirrored for parental care in males or in the lower ranking females? Will that have more of an influence on them than it would on the dominant females who do not tend to young?
Yeah.
Or are they low in oxytocin? There's all sorts of questions here.
This to me,
if Nemo hadn't left.
Yes. So yes, to answer your question, Marlin would have turned into a woman and he would have mated with his son. Are you happy now?
No, I wasn't going there. I was just going to say he would get Amon back.
Yes, Marlin would turn into a female and then he would mate with Nemo. So there you go.
That's nature, not revealed in the Disney movie. I'm finding some interesting parallels between this study and the prairie vole, meadow vole research, which is some of the leading research into the oxytocin vasopressin system, where you have prairie vole. I think it's I'm going to get it mixed up. One of the species is monogamous, and the other species is not. And the monogamous species, the male sticks around and helps with rearing the babies, and the other species, that doesn't happen. There's mating, and the male takes off and goes someplace else. And oxytocin levels are different between the males in the different species. So you have higher oxytocin levels in the monogamous species than you do in the non-monogamous species.
Yes, and prairie voles, as far as I can tell, are monogamous.
Yes,
prairie voles.
This one.
Yeah, so definitely these are all kind of intertwined, but it kind of just leads back to my common thread on this show, which is that it's hormones.
It's all hormones.
We're all ruled by our hormones, which brings me to my very next story.
Okay.
It's about female fruit flies becoming more aggressive towards each other after sex. So
what?
Yeah.
Why would they be more aggressive after?
You'd think after they chill out for a little bit, they have some egg fertilization to tend to,
Right.
No, they get really, really aggressive. They start headbutting each other. They challenge each other. So the new hypothesis is that it has to do with specific proteins in fruit fly semen.
This is a new trend we've been seeing in the last few years of proteins or RNA that's in the semen.
Mind control
things.
via seminal fluid.
What? Yeah.
Yes.
Okay. Go.
So
Go on with this study.
A team of researchers from Oxford University, they examined hundreds of fruit flies. They assessed the impact of mating on female fruit fly behavior and to what degree it alters their levels of aggression. So what they did first is they took fruit flies and they tested them for aggression levels if they are virgin or if one of them had just mated. But then they tested them looking at if they had mated, but there had been no delivery of fluids. So basically they took sterilized males and still let them in, and they mated, and then they saw what would happen. And it really looks like the aggression is directly related to the transfer of fluids.
What would be causing aggression though? So is that, I mean, normally we associate aggression with testosterone, but is that, I mean, would that be transferred?
They don't think it's testosterone. So they think it is the sex peptide carried in seminal fluid that binds to sperm. And they think that this is also, so they also found that this specific peptide was involved in elevating female aggression. So something about this peptide is directly causing the aggression, as far as they can tell. So there's a few ideas of why this might happen. So one would be that they want to, that they're just being aggressive to everyone, males, females, whatever, because they don't want to be mated with again. The other option is that they're protecting resources because now they need them because they're about to grow babies.
Mm-hmm. Right.
But,
it's like, step off. This is mine.
yeah.
I need resources. I need the energy to support the eggs and the sperm these offspring that I'm going to be developing soon.
Right. And so, yeah, so the weird thing is that it was always if there was fluid transferred, but it was regardless of whether or not the females produced eggs afterwards. So reproduction was not a contributing factor. It was only the transfer of this material. Yes. So what they're taking from this information, so this is absolutely crazy. We don't know exactly what the peptide is, if it's the peptide specifically, if it's something linked to the peptide, what's in the peptide that's causing it. All of this stuff is TBD. But in the meantime, they don't know if this is a positive or a negative. You would assume it's a positive because it's something that exists and has maintained. But knowing whether female aggression is beneficial helps understand fruit fly population dynamics. So, for example, having more aggressive females might result in females doing less well in the wild. So if it's negative, that means they could use female aggression to control pest populations. If it's a positive, then if sterile animals get out by pest control efforts, anything like that, then reduction in aggression would be a good thing to control population. So these are all things kind of to be considered. But I just think it's fascinating. There's yet another case of mind control via seminal fluid.
Yeah, and one that obviously transfers to humans.
Right.
What?
Yes. Uh-huh.
What?
Mm-hmm.
Yeah, I mean, because that's what always happens. Well, never mind.
Right.
Yeah, never mind indeed.
Never mind.
Yeah. So anyway,
yeah. I mean, it just makes you wonder how often, I mean, this is something that's being found more and more often. How often is there something in seminal fluid that changes behavior in animals? How often?
Mm-hmm.
How many
Absolutely.
species? Which species? I want to know.
I want to know. And then actually, I'll really quick just tell you my last parental story, since it's just a mere few sentences, but it's right in line. It's about tadpoles, poison dart frogs. They are the males will actually transfer tadpoles to ponds when they grow up. So they lay their eggs in plants that are above the water line but have kind of a cup shape, so there's water inside. The offspring hatches, they drop down into a pool, and then if they're not moved, they eat each other.
Uh-oh.
Normally, dad shows up, he dips kind of his rear end into the water, one or two tadpoles jump onto his back, he goes to a pool, he deposits them, he comes back, he makes a few trips, everyone's dispersed into their own separate rooms so nobody fights and eats each other. However, it's been recorded,
Just like in humans.
it's been recorded that if other frogs go to a pool, sometimes they'll try to get on that other frog too. And so a new piece of research from Vrije Universität Brussels and Triel University in Germany, those researchers took these little tadpoles and they tried males, they tried unrelated males, they tried females, they tried males and females of a different species, and they tried 3D printed frogs. And the tadpoles tried everything except for the 3D printed frogs. And as I said in the show notes, for them it is any ship in a storm. Any dock in a storm. Any what is the phrase? Any
frog in a storm.
Any port.
Isn't that it?
Any port in a storm.
In a storm.
Gosh. Any port in a storm. So they're, the frog is their port. So the tadpoles, they don't care who is coming to get them, mom, dad, a far off cousin. As long as it's not plastic, they're down. Because otherwise they'll eat each other.
And along the lines of cannibalism, we are going to be talking about not cannibalism. I have sent out an invite to Bill Schutt, the author of Cannibalism. Hopefully we'll be getting an interview with him sometime soon to talk about his book on the subject.
Ooh,
Why do animals of the same species eat each other? Why is it
I
not
always say,
Convenience.
any steak in a storm. That's the phrase, right?
There you go.
That's
That's
what
the
Blair
phrase.
Any steak in a storm.
Yeah, and along the lines of your fruit fry,
Yes, the fruit fries.
fly, the fruit fly mating story. Next week we will be interviewing Richard Prum, who is the author of a book on mate selection, the evolution of beauty, how Darwin's
Ooh.
forgotten theory of mate choice shapes the animal world and us.
Neato.
Yeah, we got some good animal behavior, kind of very Blair's Animal Corner centric kind of interviews coming up.
Yay.
Hopefully. Yeah. So just letting everybody know. We have come to the end of the first half of our show. It is time for us to move on up, take a little break, and have more science coming to you in just a few moments on This Week in Science. Stay tuned.
Explain the things you heard with more than intuition. The line of reason shows the way to go. No conclusion. The methods of hypothesis and patience are the only things I need.
Hey everyone, I hope that you're enjoying the show and that you will continue listening. Right now, I just want to tell you about a few things. Remind you once again that on June 10th and 11th, we will be in Philadelphia at the Young Innovators Fair, which is a wonderful fair, science, a STEM-focused fair / festival expo for the youth. And it should be so much fun. We will be podcasting both days, I think 9 a.m., 10 a.m., 10 a.m. to 5 p.m. both days. It's going to be crazy. And we're going to try and be broadcasting live to our Facebook channel and get the broadcast going for everybody so that you can enjoy the broadcast podcast as well. So if you're interested, head to younginnovatorsfair.com for information. Again, June 10th and 11th in Philadelphia. TWIS also has merchandise that you might enjoy. So if you do want to come to that fair and you want to show up and you want to wear a TWIS t-shirt in support, you can do stuff like that so easily. All you have to do is head over to twis.org. And when you get to twis.org, you click on a little link for our Zazzle store. So you click on our Zazzle store link, that'll take you right away to zazzle.com/thisweekinscience, which is where we have all of our TWIS goodies, t-shirts, hats, mugs, Blair's Animal Corner art items from the last couple of calendars. And I hear she's working on new calendar art. This is very exciting, everyone. But anyway, click on that Zazzle link at twis.org and peruse to your heart's content. Buy some TWISy items and support TWIS in your endeavors. If you're not interested in stuff, we totally understand that, but we would appreciate your support to be able to continue producing this show in a very timely fashion, getting things done when they need to be done. You can support us easily by just donating. So there's a donate button along the sidebar on the twis.org website. Click on that. It'll take you to an easy PayPal interface where you can use PayPal to get into the website. Also, up in the header, Patreon. There is a link to our Patreon page. And Patreon is a wonderful community where you can support creators in an ongoing fashion as they're creating stuff. So you can join the Patreon community, be a part of the TWIS community, support us, and also support your other favorite podcasters, artists, and musicians at the same time. It's a great platform for being able to be a patron of these new digital arts these days. So if you click on our Patreon button, it'll take you to our page, patreon.com/thisweekinscience. Click Become a Patron. You can support us at various levels to allow us to really keep this show going and buying equipment that we need to be able to get things done. That's right. Anyway, heading back over to twis.org. That's the main source for all this information, so you don't have to remember all of those links. twis.org makes it super easy. And all of you, if you're beyond the financial aspect of things and you just don't want to be involved in any of that, but you love our show, share us with people you know. If you know people who would enjoy a little bit of science wonderment in their lives, a little sciencey goodness, tell them about TWIS. Share us on Facebook. We have a Facebook page, facebook.com/thisweekinscience. You can share our Facebook page and our Facebook feed. Right now we're broadcasting live there thanks to Infinity Networks and Brandon over there. Thank you. You can share that with your friends. Say, "Hi, I'm watching this right now. You should watch it too." So if you're watching on Facebook, tell people about that. You can also share us from YouTube. You can go to twis.org/YouTube. That's our YouTube page. You can watch, you can share the videos, you can tell people all about it. On YouTube, it's great because we even have in the descriptions, Fada does a great job of breaking everything up into the stories. So you can go immediately to stories that you thought were great and share those stories with people you know just by using the time codes. So all sorts of wonderful, fabulous ways you can share TWIS. Our podcast is also available iTunes and Spreaker and all SoundCloud and all sorts of different places there. Wonderful ways for you to share TWIS, all sorts of platforms. We just want to get out there to help people learn about science and become more and more excited about what the world holds. Thank you for your support. We really could not do this without you.
If you could travel by thought to a mystical place, why go to book signings and vie for shelf space? Why would you wait for your agent to call you and try to convince you he's worth 12%? Why would you bother with talk shows and a crazed publicist? Why deal with the people that repeatedly insist that you show them real proof that your powers exist? Hey, convince some real skeptics or cease and desist. Trust me, 6 months from now, you folks will not be missed.
What is the moral that we all...
And we are back with more This Week in Science. We're going to keep on moving up. Gonna keep on moving.
Hooray.
Gotta keep on moving. I feel really random right now. Sometimes some kind of random, right? Things make sense to me, but they don't make sense to everybody else. It can be kind of random.
The world is random. I've heard.
And now a study suggests that artificial intelligence bots should be random as well. They shouldn't know everything and be perfect.
Oh no.
Yes, this is good. We need to create robots with personality imperfections. This is what we need. We need hiccups.
Them to
be just as unreliable on some level and quirky as us humans.
Absolutely. And so a new study that is just out this last week worked on this exact idea, wanting to know how bots, AI, artificial intelligence, could help people solve problems and what the best kind of bot personality for helping people do that would be. And so Hirokazu Shirado and Nicholas Christakis at Yale University asked volunteers to play an online game. And each person involved in the game controlled one node out of a network of 20. And the nodes had different colors. They had green, orange, or purple. And people could change the node color at any time. And the goal of the game was for no two adjacent nodes to have the same color. The trick here is, though, the people who were playing it could only see their color and the colors of the nodes that they were connected to. And so sometimes there were conflicts that came up between different nodes in the network. And to be able to settle conflicts with the neighbors that they, a couple of neighbors away that they couldn't see, like they changed their node color, and then the neighbor two nodes away would change their color, and it would pose a conflict to the node in between, right? So how do they solve that conflict? The network had to achieve this goal of having all of the nodes not sharing their same color next to each other, etc., within a 5-minute time limit. And then if they did, they got cash money for being awesome. They recruited... Yeah, they recruited 4,000 players in all, which is awesome. And then they put them in 230 randomly generated networks.
4,000 people? So
overall.
the cash reward's like, you get $1. You get $1.
Yes, this is science. I didn't give them much money, right? Some of the networks had each node being controlled by a person. So all of them, all 20 nodes were controlled by a person, 20 different people playing. Others had 3 of the most central, well-connected nodes already colored so that they fit one of the solutions. Some of the networks had 17 people and 3 bots, these artificial intelligence programs. And in some networks, the bot-controlled nodes were central, and other times they were off on the edges. And then the bots also varied in how they played the game. So how much randomness went into their choice of color. And so in some networks, they every 1.5 seconds, they picked whatever color. They were not random. They definitively picked whatever color differed from the greatest number of of neighbors. And this is what most people playing the game tried to do. But in the random noise, sometimes it was 10% of the time they would just pick randomly as opposed to choosing logically. And sometimes the randomness was 30% of their choices. 30% of their actions were random.
So they might pick yellow even though their neighbor's yellow already.
Exactly. Just because it was a random choice and it wouldn't be on purpose. Yes. So all of the networks with their bots, they know that their artificial intelligent networks were good and were good at this game because they all performed the same as networks that had all people. So if there were bots in the game, it didn't change the result. They all performed the same. Bots didn't muck it up.
Same simple strategy. They can employ it just like a human.
Exactly. So the networks where the bots were central and then randomized their decisions 10% of the time did better than the all-person network, all-human networks. They solved the game within the time limit 85% of the time versus 67% of the time for 100% human. And they dramatically reduced the median time that was spent on the task. It was 103 seconds for this centralized 10% random bot network versus 232 seconds for the all-human network. So this time difference was really decreased. And the 0% or the 30% randomness did not have this effect. So there's something about this just a little bit of random, but not too much random. You wouldn't think 30% would be too much random, but it was.
I sort of think though the centralized location, right? It is sort of like starting a game of tic-tac-toe and there's already a 0 in the middle. I mean,
right.
I can see how this being very central and being like, okay, here's what we're putting and we're going to lay it down like this. And as they're going through the 3 or I guess 9 different options, how to set this thing up. Well, it's really, having a central core that's already decided, and then that would proliferate out in both directions at some point. So I kind of get how that works, but not so much why being more random or less random, unless it's in conflict. The more random is in conflict with itself. I don't know.
Yeah, something that the randomness seems to have done is that by this random, just picking a color that sometimes conflicted with their neighbors, sometimes was great, this noise affected the way people started making their choices. And so people that were playing the game seemed to start kind of making these conflicting choices, suggesting that there was this learning effect. And that even though we might have really sophisticated, smart AI programs, that people can learn from these dumb, quote unquote, dumb AI programs as well. And then this randomness also, there's another idea here. We know that there's a certain amount of randomness inherent to evolution, mutations, for example. That this little bit of randomness might be the thing that does elicit change and a better solution than absolutely no randomness at all.
Yeah, but I think it also depends on how stubborn it is. Because I'm picturing an experiment I haven't actually seen all the way through and how they're doing it. But if I'm getting this right, and you have the ability to just change your color based on what you see left and right, having something just as aggressively obstinate as your neighbor picking your own color might tell you, oh, they're doing that because they can see what I can't see, which is the next node, And this is the flows coming this way. We're doing the wave this way now. I thought the wave was going to go that way. Oh, it turns out it's going the other way. So I'm just adjusting to an obstinate neighbor or to a neighbor who I assume can see something. I was basing this off of more information than I have. So, and that can work both directions from that AI being obstinate and saying, it's yellow. I don't care if both of you next to me are yellow. Doesn't matter. I'm picking yellow. And therefore, you're going to have to make your solutions based on that going in each direction.
There is, looking at how a
quotient. That's it. Less randomness and more like being absurd and saying, it starts right here.
Right, exactly. Yeah. And so, maybe, with the centralized aspect of it, the obstinate aspect of it, there are a couple of things that we can consider as AI becomes more integrated into systems as we move forward, and potentially becomes integrated into decision-making systems that, maybe are involved in lots of things that we do in our lives, that maybe this little randomness will make computers even better at ruling our lives someday.
It's just more obstinate. Like, so you're trying to complete a maze with a robot partner. And you go, I think we should go to the left.
No, we're going this way.
No, but I think left is no. Okay, and then the next intersection. Okay, well, why don't we go right? No. Okay, why am I even here?
From this article in Science Magazine news section by Matthew Hudson, he ends the article with a story that's told by one of the authors of this paper. He's the author, Christakis, says he has a friend who's wealthy but considered by many to be difficult. He told me he's never been asked to be on a board of directors because he's very contrarian. When I showed him this paper, he said, "This is fantastic. This vindicates my way of being. This is why jerks like me should be on every corporate board."
Yeah, there it is. Yeah.
Uh-oh.
That's it. That's totally it.
That's what you're getting with. Yep.
Oh, no.
Yep. Oh, dear. So moving on from randomness regulating our decisions, how about microbes, Justin?
Huh? Okay. Single-celled microorganisms cover practically every surface on this planet, including human skin, but they're also as much of the inside of our bodies as are our own human cells, bones, and other organs. They are part of our immune system, in charge of our metabolism, and as we've been learning lately, can even influence our behavior, our decision-making, our choices. Now, Duke researchers have shown that microbes can manipulate the molecular machinery of host cells, triggering patterns of gene expression that consequently can contribute either to health or to disease. Work was conducted on zebrafish and mice, and they say it could have implications in human inflammatory bowel diseases like Crohn's disease and ulcerative colitis. This is being published in the journal Genome Research. Scientists have been finding tons of links between our trillions of residential bacteria, virus, and fungi, and all of these human conditions. Enter John F. Rawls, author of the study and associate professor of molecular genetics and microbiology at Duke University School of Medicine. Rawls says an important gap is remaining in our understanding of how these microbes are actually influencing health and causing disease or holding off disease. And in this study, they specifically looked for the impact of the microbiome on specific regions of the genome, which regulate genes that are turned on and off at a given time in a given tissue. They were looking at the gut. They compared these genetic regions in two sets of mice, one that had their bellies loaded with microbes. In a nutshell, what they discovered was that genes normally active to allow microbes to be present were turned off by the microbial load. They don't know how they did this. And this is one of the annoying things about reporting on specific genes, is that they don't give every specific gene like a user-friendly name. This is HNF4A, but we'll just call it the tummy gene for now. The researchers noticed that the microbes were turning off this tummy gene that would normally not create, it would allow the microbes to be there and would have no inflammatory reaction whatsoever, which is an important, they say, genetic trait. This is one of these ancient genes that allow microbes to live within the gut, right, of these mice and of us and of anything that's got microbes in them. They share this gene in common. But yeah, somehow they were blocking protein landing spots in the DNA, or they may have been might inactivate the proteins, the DNA binding activity, and modifying the protein itself. No, the exact mechanism, but the expression of the gene itself was being turned off in these experiments, which is something they hadn't seen before. So if they can figure this out, how it's doing it, this could create a whole new microbial, pharmaceutical strategy for activating this gene and those that have it turned off, which will allow their digestive systems to work properly.
Yeah. So, or maybe it's different species of microbes. You know, some species turn it off and allow inflammation to run amok, or maybe it's like during, you know, maybe there are certain synergistic times in people's lives when certain diet factors and bacteria and other things all align to allow the microbes to turn off this gene and allow the inflammation to actually start causing a problem. I mean, I guess the question is, would this evolve because inflammation creates a more hospitable environment for the microbes that are there?
Or inhospitable. I think it's sort of interesting that it's with the large microbial load that the inflammation takes place, that it turns off the gene that makes it so it's okay for it's almost like somebody at the door saying, okay, we're overcrowded. I'm going to start flashing the lights off and on. I know it's annoying. I want some of you to leave. Right? It's almost as though it could be a self-population control device. It could just be an affect of the population, like you said, that's there, of specific microbes that are there that aren't, you know, that got into the room but shouldn't have, or aren't normally there. But I think the really interesting thing too is just that we think of our genes as this set blueprint. I mean, we're less and less so now the more we've been doing the show. Epigenetics and everything else that's taking place. We know the environment has a factor, but the idea that the microbes themselves can make genes that we already have that are functioning and just turn them off, or turn them on, or change the way that they interact, or express themselves. It's really fascinating. Again, it's another one of these stories about the gut microbiome that tells us we know we're just at the beginning of understanding a whole host of directions that this is going to take us.
I get it. Host.
That's right. Ha 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 ha.
The whole story was just so I could say that. Yeah, it was just all the lead up to it, and it wasn't even that crescendo. But yeah.
Our ancestors had these interactions, and we descended to continue to have these interactions, even though they may or may not be beneficial to us. Right?
And then what's you know, what's beneficial to us right now might not be, or what's not beneficial to us now might have been a hominin ago, or several generations ago, with a different diet or a different condition, or, you know, different genes. Like there's so many questions on this. Like the things that, again, I keep harping back to the 6 or 7 hominins that were on the planet at the same time. We had different genes of areas. And so, you know, there could be microbes that persisted in the hominin for 500,000 years that are now in us for the last, 50, 60,000 years. And it's still a new environment. Like there's so many questions that we have yet to be, or might not ever answer. But a lot of directions we can go down to try to figure this out.
And I'm so glad people are trying to figure it out. I love it. That's interesting. Oh, microbes, try to control me, will you?
Yep. Yep, doing it right now.
They're doing it right now. That's right. Oh, yeah. There's another study, I think, out of Ireland. Microbes from your gut control your anxiety levels. Something they're related to your anxiety, maybe. Anyway, yes. American trees are moving like the
To
ants.
follow their
That's right.
desired climate.
And that, yes, we've talked about this before. Climate is changing and the trees are moving accordingly. However, new study
Come to
looking
California.
at
You got plenty of room for trees.
well, this is the interesting thing. Trees on the east seem to be moving to the west.
The West is the best. Get
And-
here.
And a new study in, Science Advances on the divergence of species responses to climate change looked at the abundance of 86 tree species and groups across the eastern United States over the last 3 decades. And they found then that even though there's this temperature shift, and you'd think that the temperature shift might be one of the main drivers of the movement of trees, this temperature shift that is moving kind of warmer weather a little bit further north, cooler a little bit, everything's moving a little bit up north. You'd think that things would be moving poleward, but they found that more tree species are moving westward than toward the pole.
And why is
But
that?
this is East Coasty trees, though, right?
This is only East Coasty trees, but
So is
the
this,
idea.
could this be soil salinity? Could this be microbial shifts? Could this be
Humidity?
the way the wind is blowing? I don't know.
And the shifts, they say, are primarily due to the movement of subpopulation abundances in the leading edges. So along the leading edges of these trees' habitat lines, the ones in the front of the charge are the ones that are making the moves the most. And the ones along the back, the stragglers at the end, are the ones that are more likely just to kind of stay there and die off. And so it's these trees along the leading edges that are causing most of this shifting. And additionally, it's associated significantly with changes in moisture availability. Yeah. And so Blair, you ding, ding, ding on the nose.
Trees got a drink.
And so species that have similar traits, drought tolerance being one, wood density, seed weight, and also evolutionary histories. They found that angiosperms are more likely to go west, and gymnosperms, like the pines, are more likely to shift toward the poles. And so they're looking at this in terms of how is climate change affecting the populations of trees? How might it affect their future movement? And what they're indicating is that this moisture ability effect is what's going to have a stronger near-term impact on how and where tree populations are moving than are the changes in temperature. However, temperature is kind of related to moisture availability as well.
One thing I'd like to see overlaid on top of this, though, is something along the lines of like deer population in the areas.
Right. Animals that might be
might
moving
eat little
seeds
baby
around.
seedling trees and then kind of keep them back, or sort of set a boundaries for them, or make it more difficult for them to grow in a certain direction. Like I'd want to see that overlaid, especially because we're talking about an encroachment area, an area where they're going into territory along an edge where deer might normally have been in this like open valley, prairie land, or whatever it is that they're encroaching on. And if they're not there,
yeah, well, there are many species shifting, and I think one of the big questions here is, as we have mixed forest populations, and evidence suggests that mixed forests are more resilient. As these populations split and the angiosperms go one way and the gymnosperms go another way, are they going to become less diverse? how is that going to affect the ecosystems? How is it going to affect the way that the ecosystems are able to support other animal life? How are they going to be able to do that? So how are these different populations going to move and change? But that said, even though there is a call of concern from from these researchers saying, hey, we don't really know what's going to happen, right? Their last statement from their abstract is, this change could lead to changes in composition of forest ecosystems, putting the resilience and sustainability of various forest ecosystems in question. They're calling an alarm, whereas there are many other researchers who work in this field. I tweeted very briefly with Jacqueline Gill, who is over on the East Coast and is a paleoecologist. She has looked at and her advisors before she became a professor, all the people she's worked with, looked at the movement of tree species over millions of years. And they're looking at vegetation response to climate change over millions of years. And in her view, things have changed. They will change again. So in her response, when I asked her about it earlier today, she said movement is a good thing. We want species to track their climates. The composition of forests changes and will continue to. The forests we have now are different than when Europeans arrived, and the forests before that. Same species, different assemblages. And so maybe she's saying the species will survive, just the way that they are put in combination with other species will be different. So alarm, don't be alarmed. I don't know.
Don't panic.
Don't panic at this point in time is what we're hearing. Don't panic. And other researchers have been tracking, speaking of researchers tracking things, other researchers from UCLA and the University of Houston have been tracking groundwater lost in California's Central Valley from 2002 to 2016, which included 2 droughts, one from 2007 to 2009, and also the most recent drought, which is more severe, from 2012 to 2016. During the 2 drought periods, a total of 16.5 cubic kilometers and 40 cubic kilometers of water were lost, respectively. And this study is published in Geophysical Research Letters. Dennis Lettenmeyer, UCLA professor of geography who led the study, said, for perspective, the amount of material associated with the 1980 eruption of Mount St. Helens was about 1 cubic kilometer. So we're talking about 40 times that amount in the recent drought worth of water being lost. And the implications of what they found in their following of groundwater and where it went and what most likely happened to it is that although there were losses during both droughts, this more severe drought recently had a lot of groundwater losses because even though farmers have shifted slightly to less irrigation, there have been more tree crops that can't be left fallow during dry years and require lots and lots of water. So the changing of the agriculture in California has affected how much water is used and where the groundwater goes. So studies like this are very important, especially for California and its agricultural system, especially if drought is going to become a more regular part of the climatic cycle as we move forward. The question is, how resilient will agriculture be in California as drought continues?
So perhaps more money on drip irrigation and concentrated irrigation.
Yes.
Finding crops that require less.
I think it might be, even though almonds have become a big moneymaker for California farming magnates, it is something that is affecting the sustainability of the entire system. So there are questions to be raised about how agriculture is being done in the Central Valley of California.
Yeah.
And
Yeah,
research.
and I've talked about this before. The Great Nothing, that area of the southern stretch of the California Valley, which is essentially a desert type area, is now almond orchards as far as you can see, and it makes no sense that we were doing this heavy water dependent crop, water resource dependent crop during times of drought. But there it is. Yeah, like you said, there's a few people who are making a lot of money growing it, and they're not going to stop.
Yep, unless something makes them.
Yes. Like regulation or just efficiency.
Regulation.
Oh, science.
Policy based on science.
Policy
nothing
based on science, that would be.
It would just be ridiculous.
Why would we think about that?
But wouldn't it be nice?
And since we're not going to talk about science and politics right now, let's talk about science and religion.
Oh yeah. Quick question. How atheist is America? Well, widely cited telephone polls by Gallup, Pew suggest U.S. atheist prevalence ranges from 3 to 11%. But in the U.S., there's a heavy stigma leveled against religious disbelief, which might make people a little less forthcoming with their answers. So this research group used an indirect measurement technique. Psychological researchers have found that atheists, based on this method of asking people vague questions, may represent anywhere from 20 to 35% of the U.S. population. The study, How Many Atheists Are There?, appears in the journal Social, Psychological, and Personality Science based on the results, just as there are and have historically been. This is a quotey voice of Will Gervais, University of Kentucky. Just as there are and historically have been closeted gay men and lesbians out there, there are probably lots and lots of closeted atheists out there who don't even identify themselves as such in anonymous polls. The authors surveyed 4,000 people across 2 studies of 2,000 people each in the nationally representative samples. They used an indirect sampling method, which gave participants a list of things to look at and then record how many of the statements, but not which specific statements, are true for them. The idea being this technique allows them to infer their overall preference for things on this list or not on the list without specifically admitting anything directly. And it has been used previously to estimate a prevalence of various undesirable criminal behaviors. Within our sample, 1 in 3 atheists in our online survey did not disclose their lack of belief, highlighting the level of stigma associated with lack of belief, says co-author Mazin Najil, University of Kentucky as well. Gervais says he was surprised just how far the indirect measurement diverged from established polls of religious disbelief. Our best estimate is more than double what the Gallup telephone polls estimate. Gervais and Najil expected a much more modest gap between self-reports and direct measurement. They say this might have potential impact for science because researchers have been developing testing theories on how religion works based on the idea that it's super ultra prevalent, like almost everybody.
Well, even if it's 35%, that's still pretty darn prevalent.
Oh no, yeah, well they're talking about the 3%.
Right, that's true. So okay, so Justin, this is my question.
Prevalent 35. Oh yeah. What?
Why do we care?
Well, because if it turns out atheism isn't that rare, it might challenge a lot of prevailing theories, says Gervais. Basically, it means those of us who study the natural foundations of religion need to question our bedrock theories and assumptions that there is this, need to believe that this idea is already there in our minds before we set about being told as children. He doesn't go into it, but I'll say, yeah, children, you can convince children of anything. But what's actually sort of interesting about this story, he goes on to say, it's important to note that the results weren't crystal clear and perfect. Their estimates are pretty noisy, says Gervais. It's 26% as a best guess, but it could be a bit lower or higher. Could be 20, could be 35. We also had some findings that made us question the validity of the very task we employed.
Well, there
The
you
author-
go. What?
The authors appreciate that even with the noise, their research was accepted for publication. Here's Gervais's summary. Social psychology has been taking a beating lately for producing results that are too good to be true. And it's a real feather in the cap for this journal that they didn't pressure us at all to put out the perfect paper, rather than just transparently communicate what we found, including the good, the bad, and the ugly.
So this is interesting too, though, because this article and more like it could then result in people being more open on actual polls. I think that's part of the problem too, is that if they think they're part of 3% of the United States and that their family has beliefs and their entire county has beliefs and maybe their entire state has beliefs, there is a pressure to not identify. And so potentially...
But if you're part of a group that makes up about a quarter of the entire population, then you're not so alone.
Not so alone.
Right. And as somebody who's been an outward extroverted atheist, right? My whole life, I have not, like, there is this thing, sort of like being the first gay man on the planet, I guess. That would have been pretty fantastic to be that, right? Because like there's people always coming up to me like, psst, yeah, I believe that's true too. Like hushed tones, like, why are you whispering? It's like, can't talk about this. Why can't you talk about this? Why is this a thing you can't talk about? People are very afraid to talk about it. They're afraid of social repercussions, work repercussions, the whole kind of thing.
I'm in a Facebook group actually for atheists, and there's a lot of outspoken atheists. There's a lot of closeted atheists, and there's people who seek support in order to come out as atheists. And you get to help them along this journey in, some state where it's not a very accepted thing to say, for them to make the conscious decision to come out, tell their family, tell their friends, all of the resulting stigma. It's pretty crazy. Actually, there was one person in the group who did get let go from their job after they came out as atheists, and they had to sue the company.
Oh my goodness.
Because that didn't follow the values system of the company. Right.
Which is illegal. But just
even though evidence has supported atheists as moralistic, if not more than individuals who follow organized religion, making moral choices. It's not very
Ed from Connecticut. Jack's Fly, you just like to push people's buttons. If most people were atheists, then you would argue that there's a God. That's possible.
Fair point.
No, but here's just the soft poll, and I'll leave it at this. If everybody in your town decided to go to church tomorrow morning, there are not enough seats in all of the faiths collectively combined. There's not enough seats to seat everybody, even if they took shifts all day, 1 hour shifts all day. There's not enough seats, and there's not enough pew seats in there for this to be the majority view in the country, in my belief.
Yeah, well.
And, going back to the scientific aspect of this study, I think it's an interesting way of getting at what people believe without directly asking them. I think that is I think using subtle techniques to be able to elucidate people's underlying drivers I think it's a fascinating way to go. And I mean, they question whether or not it worked out okay, but more study should be happening. We should get more study on this for sure.
Yeah, absolutely. And this is important to recognize, because we make a lot of decisions as a country based on the idea that religion is a big part of our society. And if it turns out that that's no longer the case, maybe it's time to readjust some of those things.
And for anyone who's listening in or watching right now, we are just reporting on this, and we are not saying in any way one is better than the other. It's just these are different ways of being. different
Right,
ways of existing and behaving in the
Right.
world.
Right. And in order
So-
to properly represent the wide swath of people that are in this country, it might be help to identify real
able
and
to
accurate
Mhm.
categorizations. Absolutely.
Yes, to have better categorizations and identification.
And God
for
bless
sure.
you all.
And moving on to our final stories for the night. Oh, this one's fun. Fata, thank you for sending me this one. I do love this. We love the dinosaurs. Love the dinosaur stories, especially the T-Rex, who used to be this fearsome beast, and now we know it was mostly a scavenger. But you should still be very terrified of meeting a T-Rex, because according to this new study of a T-Rex bite strength, they have one of the strongest bites in the history of animals. That was from Scientific Reports. They lassoed crocodiles. They lassoed crocodiles and got them to bite on force transducers. One of the researchers says, "This is quite a spectacle. I call it bull riding for scientists." They took what they knew about the crocodile jaw muscles and bite forces and then used that to make their own 3D models in a computer that could reveal the T-Rex's potential bite strength. And the researchers say T-Rex was basically eclipsing the highest forces known for any living animal today. So those big jaws did deliver a pretty hefty bite, which was probably important for this scavenger species that needed to bite into bones to suck out the lovely marrow.
So, but
Delicious.
just like with alligators or crocodiles, their bite force is very strong, but their opening force is not. So you can hold an alligator's mouth shut with your bare hand.
Right.
So with a T-Rex, if I just sat on it, would it not be able to open its mouth again?
I'm not exactly
grab it,
sure of the
grab its mouth, hold
musculature
it
for
closed.
opening. Yeah.
Okay.
You little dinosaur.
Just checking. It might be good to know.
So what they equated it to is this 8,000 pounds is like setting 3 small cars on top of the jaws of a T-Rex. That's basically what's pushing it down. And they say that although this T-Rex had this really, really strong bite, this is not by any means the strongest bite ever. They say that the biggest, strongest bite ever probably went to the largest crocodiles that ever existed, that were probably 35 to 40 feet long, with bite forces around 18,000 pounds.
Wow.
So definitely not something I'd want to see on a fan boat tour.
And those were likely killers as well.
Yeah,
Not just
exactly. They were the killers, not just the scavengers. So, you'd like a little bit of salt if you're taking a bite on a nice meaty meal, right? And we all
Love salt.
the sea salt these days. Well, some researchers published in Scientific Reports of their analysis of 16 sea salts from 8 countries. And lo and behold, microplastics within each and every one. Not a lot of microplastics, not a lot, but little tiny, tiny microscopic particles of plastic were found. They used filters and spectroscopy. They found 1 to 10 particles in the 16 brands of salt. They didn't report the brands. And most of these fragments were shards of old plastic products that showed signs of weathering. So this is not contamination from any packaging material of the salt itself. And the materials, we don't know how much of them could affect human health. At this point in time, the researchers estimate that people might consume around 37 microplastic particles from sea salt per year if all the salt in their diet came from sea salt. But there are other places where you can get lots of salt, and there is a study that suggests that shellfish-loving Europeans may consume up to 11,000 microplastic particles a year. Still unknown how that plastic affects human health.
I'm sure it's fine.
I'm sure it's fine. It's great. My salt tastes wonderful. Little plasticky.
Oh man.
My salt tastes wonderful.
Plastics will be our legacy, whether we like it or not. That's
They are already.
That's what we're leaving behind. It's just so many plastics.
This beautiful plastic beach. It's lovely. Like plastics through the hourglass. So are the days of our lives.
Yes.
All right, who's got some more stories?
I have a fun story about dogs. So if I told you that you had to do a 20-minute presentation for a couple thousand people in about 5 minutes, no time to prepare, how would you feel?
Yeah, awesome. Where'd you find 2,000 people?
Most people who don't do a weekly science podcast
Oh, yeah.
would be pretty stressed, particularly kids. Kids are very commonly stressed about public speaking or about doing arithmetic. And so a study from the University of Florida put these children in stressful situations, and then they were randomly assigned to either experience that stressor with their personal family dog present, with their parent present, or no social support. And as you may have guessed, having a pet dog present when a child is undergoing a stressful experience lowers how much children feel stressed out. Children who had their pet dog with them reported feeling less stress compared to having a parent for social support or having no social support. It seemed like having the parent there didn't really help or hurt the situation, but having the dog there, that made a difference. They then tested saliva to see if this was related to cortisol, to stress hormones. Oh, we're back to hormones. And they found that kids who underwent the stressful experience with their pet dogs, their cortisol level actually varied wildly. So they were reporting themselves as less stressed, but whether or not they actually had less cortisol depended. If they actively solicited for their dogs to come over and be pet or stroked, their cortisol was lower. If their dogs hovered around or approached children on their own, their cortisol went higher. Maybe they were stressed out about keeping tabs on their dogs. Who knows? So it was kind of all over the map. But in terms of self-reporting, having the dog there reduced stress. So
Dogs,
Yes.
good for stress. Better for stress than parents.
Well, what they're saying is, actually, it's pretty interesting, is that middle childhood is when children's social support are expanding. So they're less attached to their parents, right?
Yeah.
But their emotional and biological capacities to deal with stress are still
Not
pretty
developed.
immature.
Yep.
And so right in that window, when they don't care as much about their parents at 7 to 12 years old, that is when they still do not know how to deal with stress. And so bringing a dog into the picture actually could help the maturity of emotional health and well-being over time. So it could help them learn how to deal with stress by having the dog there. That's kind of the implication. So
Ed from Connecticut says, try that with a cat. Not going to work. I beg to differ. I bet if a kid had a cat to pet.
yeah,
would help.
absolutely. I
Wow.
mean, I've certainly, when I've been house sitting, watching a movie that's, a thriller or dealing with something that's stressing me out, maybe having a bad phone call. If the cat's in my lap, I definitely feel better.
Yeah, and it might not just be the dog, just having a pet.
Yeah. Therapy animals are a real thing, and we're
Mhm.
finding that out more and more.
Absolutely.
Mhm.
All right, are you going to talk about the bees?
Oh, yeah. So where are all the bees in Michigan? New study of native bumblebee populations in southeastern Michigan cities found, not surprisingly, that increased urbanization, as measured by the proportion of impervious surface area, was tied to decreases in both the abundance and diversity of bumblebees. However, that pattern did not hold for Detroit. There, the higher urbanization seemed to be correlating with increased bumblebee abundance when compared to less urbanized areas. So everywhere else that they studied, 30 different sites, the more urban it was, developed it was, the less bees. But then they got to Detroit, and it was the densest urban landscape that they studied, and it had the most bees.
They have a sugar plant over there or something? What's the deal?
No, why?
So, University of Michigan's students who conducted the study suspect that the large amount of vacant and idle land in Detroit may be boosting bumblebee populations by providing tall grasses, rotten trees, and plenty of nesting sites and flowers and food.
Sorry, Detroit.
So,
Not good
Your
necessarily.
loss is the bees game.
Economic
Sounds-
decline
Yeah.
is that the bees will move in to your neighborhood.
The bees, though.
So this is maybe high density urban neighborhoods should implement outdoor vegetation, that there should be more open space. There should be more natural areas.
Yeah,
to
and so this
bring
is
more
just further
bees.
evidence for those things that we call those natural habitats, even if they're, you know, just land that's set aside to just grow wild. I mean, if it really is vacant land where the weeds, the flowers have grown, the grasses are tall, that you know, there's a few hollowed out tree stumps here and there that aren't getting removed and hauled away. That's like the easiest thing to implement anywhere, is just to leave the land alone. Just don't do anything with it.
Let the land alone, but keep doing the
If you do it-
science.
And there's not enough of that in California. I think I always marvel at how manicured and manipulated and managed the land in California is. I mean, it's a big state, but the Central Valley is diced and sliced up into the smallest possible portions of micromanagement.
Mhm.
And I think we need to, as a statewide initiative, and we got the right governor, figure out a way to convince them to just create not state parks so much, more like county refuges for nature. To just not for humans to walk around and take pictures, but just let the weeds grow. Just let the
Yeah.
flowers be there.
Let
Just
it grow.
Don't cut it down. Don't go in there with a weed whacker. Certainly don't use one of those leaf blowers. Just leave it alone. Just leave it alone.
Well, we hope that you will not leave us alone and that you will join us again next week, because we have come to the end of our show.
We did it.
We did it. We've run through all of our stories. Once again, I want to remind you, Young Innovators Fair, June 10th and 11th in Philadelphia. Website, younginnovatorsfair.com for more information. And we will be there, and we hope to see you there as well. It is time now for, it's time now for me to do Patreon sponsors. You guys ready?
Yeah.
Are you guys ready for this? All right, I'm going to make it go right now. Dun, dun, dun. We have a new video. It's the same video, but it's a new video. Thank you, Patreon sponsors. Chris Clark, Paul Disney, G. Burton Lattimore, John Ratnaswamy, Richard Onimus, Byron Lee, EO, Kevin Parachan, Tyrone Fong, Andy Groh, Keith Corsell, Jake Jones, Charlene Henry, Brian Hedrick, John Gridley, Steve Bickle, Kevin Railsback, Gerald Sorrells, Ulysses Adkins, David Friedel, James Randall, Bob Calder, Mark Bizarros, Edward Dreyer, Trainer 84, Layla, Marshall Clark, Larry Garcia, Randy Mazuka, Tony Steele, Gerald Onyango, Steve DeBell, Greg Guthman, Patrick Cohn, Ksenia Volkova, Daryl, Maroon Sarang, Alex Wilson, Jason Schneiderman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Richard Porter, Rodney, David Wiley, Robert Aston, Brendan Minish, Dale Bryant, Aurora Lee, Todd Northcutt, Arlene Moss, Bill Kersey, Ben Rothig, Darwin Hannon, Rudy Garcia, Felix Alvarez, Brian Hone, Orly Radio, Brian Condren, Mark, Nathan Greco, Hexator, Mitch Neves, Flying Out, John Crocker, Christopher Dreyer, Artyom Shuwata, Dave Wilkinson, Steve Mashinsky, Rick Ramus, Gary Swinsberg, Phil Nadeau, Braxton Howard, Salgood Sam, Matt Sutter, Emma Grenier, Philip Shane, James Dobson, Kurt Larson, Stefan Insama, Honey Moss, Mountain Sloth, Jim DePoe, John Maloney, Jason Olds, James Paul West, Alec Doty, Aluma Lama, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Mishkan, Aaron Luthen, Marjorie, David Simmerly, Tyler Harrison, and Columbo Ahmed. Thank you for all of your support on Patreon. And if you are interested in supporting us on Patreon, you can find information at patreon.com/thisweekinscience. Remember that you can help us out simply by telling your friends about TWIS. Again, also, don't forget to email me with your ideas of how science is helping you in your everyday life. What has science done for you lately? Email me, okay? On next week's show, I want to read your response. Also, we'll be interviewing Richard Prum about his book on the evolution of beauty, and it should be lots of fun conversation there. Why and how has beauty evolved? What? Broadcasting live online at 8 p.m. Pacific time on twis.org/live. You can watch and join our chat room, but don't worry if you can't make it. You can find our past episodes at twis.org/YouTube and twis.org.
Thank you for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory. Or if you have a mobile type device, you can look for TWIS, the number 4 droid, app in the Android marketplace, or simply This Week in Science and anything Apple marketplacey, as well as something called Stitcher, which I still don't know what that is.
For more information on anything you may have heard here today, show notes will be available on our website, Kiki website.
Huh? Do we have one?
Yes, on our website. It's
Our website. Our website is www.twis.org. That's TWIS.org, where you can also make comments and start conversation with the hosts and other listeners. So everyone flock back to the twis.org site. It's back in action.
Or you can simply contact us directly. Email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in your subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We will be back here next week with a guaranteed 10% randomness, and we hope that you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
And now we are in the after show. Don't you know, don't you know, don't you know? We are in the after show. Tiny Spicy's among the TWIS. I'll just put them right there. Where are you, Blair?
I'm
How's
here.
it going?
Hi.
Tiny Spicy wants to talk to you.
No, Spicy.
I want to talk to you.
Get out of here, Spicy. No one wants to see you.
He's
Yuck, I
holding
hate
his
it.
head in his hands.
Oh my gosh.
Oh, don't you like me? Oh no. I
Nobody
don't-
likes you, Spicy.
What is going on? Yes, Hot Rod. It's not me. Spicy has 2 left hands.
Stupid Spicy.
I would like to thank my friend Justin Silver for spending hours helping me fix the twist.org website.
Yay!
He dug into the site and he fixed all of the hacking. He found the hacks, he pulled them out, he fixed it. I do need to now make a new website on a new server though, because, well, not a new website, but I need a new server with better security. Security, so that factions that you don't want in your website, your website, don't get into your website. That's what I would like.
Yeah. Oh gosh, you have to make a brand new website. That's like a lot of oof. Oof. Well,
I don't have any bushes.
I know nothing about it, but I'm happy to help.
Thank
Let me know.
you.
I'm just taking a picture of Spicy.
Teeny tiny gum. Doesn't have any gum. Why does he need gum? He wants to know. Why do you want gum? Why do you need gum? Why do I need gum? Ah. Ah. Well, yeah, and our website, it was copy paste and then we modified it. And so it was a bunch of work to make it happen. And I have all this backlog of years of TWIS website stuff. So there's a big database and oh no, identity 4, someone got a password. That sucks. That's probably what happened with my website. Passwords. But I've changed them again. I changed them multiple times, many times, and unlike John Spicer, I will not give them out in a press conference or my Bitcoin numbers or whatever it is. There's a phone number. It's 7 Alpha Never mind. He's gonna cry into his left hands.
Gross.
I know you love the hands so much. I'm just gonna put them right here. With the one that says "Hi, Blair," right there. Hi, Blair.
I know, which is worse, Spicer's face or the hands?
Our two left hands.
No,
What
haven't
is
you
your
noticed this is
favorite?
not how he does his White House reports.
Yeah.
This is not how he takes questions.
Yeah.
What was one minute he's hiding in a bush. There's been a bunch where he's just like doing an audio podcast version of it, where he's like he doesn't have to have the cameras on him.
Yeah.
So this is gonna be the next version. Okay, I've come out here to give a version of what may or may not have been the intention or the desire or the overarching meaning of the words said by the president. It may or may not have meant that he did or didn't hear, think, or believe the statements that he said at the time, directly before or after he said them. Hopefully that's clear, and I'll take no more questions. Such a rough job.
So
It's
rough.
always a
Oh
job.
my
You know,
gosh.
though, I got to tell you,
I couldn't
that
do
has
it. I wouldn't
always
want to
been
do
a
it.
job that I wanted to do. That has
Yeah.
always
Yeah.
been a gig that to me looked like the most fun out of everything that goes on in politics. That one looks like the most enjoyable. Like I would thrive having that be my gig. I would really love it. I think honestly, I could do a better job than Spicer. I could do a much better job than he's doing. Much better job. He gets, you know what the problem is? He now perpetually looks flustered. And you can never do that. You can never do that. You got to get up there and smile. When somebody says something, and who did I learn this from? I think I learned this from
You're just
Buchanan.
smiling.
Pat Buchanan. Pat Buchanan was saying the way that he learned how to debate. He might have learned it from somebody else, but the way he does it when he's on camera, when he's debating, and somebody says something you disagree with heavily, you just grin, show your teeth. It makes the other argument look kind of ridiculous,
Like a friggin' Reese's macaque.
Like a macaque. Yeah.
just bury your teeth.
Don't just smile at them. Do it in the way that the other ape do.
But by looking
Show
flustered,
you all my teeth.
he just it's like red meat to the White House press corps wolves. If you just smile, if you laugh when somebody says something. Oh, here we go. Okay. All right, next question. No, I get it. That one was a joke. All right, go on to the next one. Yeah, it wasn't serious. It's the same question. Okay. I'm still smiling, but again, I feel like I've already addressed this. I'm going to go on to the next. Seriously, you've got to be able to come up with an. Okay, maybe this isn't my calling. Maybe I would lose it pretty quick. I'd be terrible at it.
Maybe. Oh, stretching it out.
But really, at the point where the poor guy must not be getting any like talking points going out or any insight into what's going on, because
Mr. President, I have to have something to tell them. You're fine.
he keeps coming out and saying stuff like, well, you read the tweet just like I did. You saw the speech as well as I did.
Just like I
You
did.
read the newspaper that I read. I guess we're done here. We both are just observing from the outside, aren't we?
Oh my goodness. Hey, you guys, I have questions to ask you.
Great.
Okay. I need to buy things for our stage in Philadelphia.
Okay.
What was I going to ask you? Oh yeah. So they're going to give us a 20 by 20 foot stage. Let me see if I can find a picture to. Okay. And the stage will have there's the email. Yeah. The stage will have draping on the back side and the sides to hide us from other vendors or other people who are there. And this is an example of a podcast, The Brick Show, that was at they do another expo that's Lego related.
Mhm.
And so this image is kind of the setup that those people had.
Mhm.
So we'll have like the draping that's around it and a table with a drape on the table. We'll have the elevated stage. There'll be a bunch of chairs out here.
Mhm.
And then they will also give us microphones and maybe a TV and a computer, which would be awesome
Mhm.
for displaying things to the audience.
Mhm.
And then, I mean, they said they just really want us to be able to show up and bring our computers and ourselves if we need them. But I think, like, you see how they have like a thing behind them, and then they have like this pop-up tent thing.
Mhm.
Do we want to get a pop-up tent?
I don't know
Or
if we
should
did a tent, but you
We
know
need
what
a
might be cool is a branded tablecloth.
A table in front, right? Something
Yeah,
that
that
hangs
says
in
TWIS
front.
on it. Yeah.
Yeah. Okay.
I just bought a few of those at the zoo. I could send you a link when I get to work tomorrow with the company
awesome.
I did. We got a black tablecloth with the logo printed on it, and it was pretty reasonable, and it delivered quickly.
Nice. Okay. Yeah, a tablecloth would be pretty easy to pack.
Yeah.
And then
Are
I can also
are we a
order.
nonprofit?
No, we're not.
Okay. Okay. Is there any sort of special status that I can use to try to get a discount on?
Haha, no.
Okay. Okay.
But then they've also got this thing like in back of them, and I was thinking, I could get like what Justin has behind him, but like, so let me think. What would be another? So I'm thinking the TWIS, the big orange TWIS logo.
Mhm.
Like what's let me find the right picture. Picture. So we'll get.
Yeah, so I guess we could do one iteration of the logo on the tablecloth and a different version of it on the backdrop. Right.
Yeah, so I'm opening. So this is what I'm thinking for the backdrop behind us.
Perfect. Yeah.
Right. Just have that printed. Right.
Mhm.
And then for where's the vector files?
Yeah, that would be perfect. And rivets
for
along the top of it and a couple on down the side.
Yeah, and rivets on it. Exactly. And then
wire them up or
yeah, Justin, don't you have info on the place you bought yours from that you could send?
I don't
Kiki?
know, it was forever ago, but I've got these little rivet things all around it.
Okay, it can't be that difficult.
And then for the tablecloth,
Yeah,
this one.
just do the black background, white writing.
Oh, you think the black one with white writing?
Yeah, just because white tablecloths, in my experience,
it'll
look
just
like
get all
garbage
dirty, huh?
within 5 minutes.
Okay.
It's just, they don't have a long life. Black tablecloths have a long life.
Okay, so we could do this as a tablecloth, but the other way, reversed.
Yeah.
I would actually make it the same kind of material as the backdrop. It'd be durable, reusable. You fold it up, you put it with the other one, you could take it to the next place.
And they're gonna put a tablecloth on the table. I know that I've done some looking, and they have like these tablecloth drapes where they're like, they're not as wide as the tablecloth, but basically they're made just to have the image in the front, and then they drape over so that they don't just slide off the table. They're like a runner with your image printed at one end of it.
Yeah, absolutely. That sounds great.
That might be good. So there's something in front.
Yeah.
Okay. So I'll work on that. No canopy tent.
Yeah, I don't
and then so just those two things for our logo stuff. Do you think we need any like brochures or displays or anything else? Thanks, Identity 4.
I think the badges and the buttons is good stuff.
Yeah, I think just
badges
the normal
and buttons
swag is fine.
Normal swag. Okay. Normal swag. You guys, we all need to bring our business cards
Mhm.
because that's
Mhm.
easy to hand out and give to somebody.
Mhm.
And then I think I'm also going to invest in a Wi-Fi hotspot so that we can have our own Wi-Fi. Verizon. So I've got my camera thing that broadcasts directly to Facebook and Twitter and Periscope.
That thing that you
And-
bought for Sketchfest that didn't show up, right?
Yes,
So
that
that
didn't
one.
show up in time. I've got that, and so if I can attach it to the MiFi, I'll get Verizon has a MiFi that it works with, and then we can also hook our computers to the MiFi, I think, and then I think it should all work, but I'll have to test it. TWIS branded water bottles, right? Lots of
Well,
things to
I have
hear
one of
here.
those. Hold on.
Contact in the desert. What's that? That sounds like a rave.
See?
Oh, look at that.
That's what the stickers are for.
Someone put a sticker on a water bottle.
And
There
I
you
picked
go.
an
That's
orange
what I
one,
do.
so it was just like our logo theming.
There you
Very
go.
clever.
Ta-da.
As I picked out these glasses to be orange and black.
Ooh.
It's
So
contact
I have
in
a
the
question.
desert.
You said 10 to 5 both days.
Yes.
So what are we doing with that?
The whole time that we're there.
Like, do I need to be prepping science experiments?
I don't
Because
think
I
we're gonna
could.
Yeah,
Good
I
luck
mean,
getting them on a plane, though.
Yeah.
so we will. What I'm hoping, Ulysses is going to be there that weekend, and what I'm hoping is that, and I'm going to check. I want to check with the people running the show to find out, like, if there's a list of people who are going to be there. To see if I can send emails ahead of time to get interviews with people who are at the expo, because I think that would be fun.
Mhm.
To talk with different people about what they're doing. We'll have to have a whole bunch of just like science stories
Mhm.
ready
Do
to
we
go.
want to dip into the past, or do we want to try to keep super duper current with everything?
Yeah, that's a good question.
Because I mean, I could certainly dip back and do I could do a compilation about a bunch of different stories about tool use or something like that. Like that's
Totally.
something that we could do.
I mean, that would be great.
Okay.
I could,
I could,
bring a bunch CRISPR or something.
yeah, and we could pretend that I'm from the future, and I could do stories that are coming out 5-10 years from now.
That's great. I like that.
Um,
You have to dress like it then. You have to dress in metallics.
Oh, yeah. So all in tinfoil, because that's how people roll in the future.
Yeah, of course.
Yeah,
With
so-
big shoulder pads.
yeah, and so this is a
No,
family.
they're never coming back. Give up. Give up on the dream. Shoulder pads are never coming back. No, they never looked good in the past. They will never be something that's socially acceptable again. We had that brief interlude in the 80s where we also thought Australia was
No
fascinating.
shoulder pads.
But that's it.
No.
It's done.
I'm
Did it
really
once,
not okay
it's
with
over.
neon either. Neon clothing and shoulder pads need to go away.
Although the big hair I could live with.
I went to an 80s party this last weekend. That was funny.
Isn't there one every weekend in Portland somewhere?
Somewhere. Yeah. It was
The 90s are alive in Portland, right? The spirit of the 90s.
it was an
90s.
80s party at a roller skating rink. So we went roller skating and I learned exactly how bad I am at roller skating.
Oh no.
Well, how long it had been since I roller skated last. It's been a while. Been a while. Yeah, no, not sharing that picture. I was thinking I could share my roller skating picture, but instead, I will just share this roller skating picture.
Is it Xanadu?
What? No, I went roller skating.
I know.
I went roller skating.
Oh.
I did.
Spicy went roller skating.
Spicy was there with you.
Spicy went roller skating too, among the skaters.
Cannot confirm or deny that ice skating occurred.
I know. Oh my goodness. I wish I had a good picture. I don't have a good picture of my roller skating outfit. My friend, maybe on my phone.
President is a strong and decisive ice skater. He's a skater. He would have been in the Olympics if he wasn't busy running a multi-billion-dollar company. President is a fantastic ice skater, roller skater, any kind of skating, skateboarder too.
Excellent skater.
Let me show you. Oh, here we
In
go.
fact, he may even skate on the presidency soon.
Here's
Wow.
here's my
Nice.
here's my 80s roller skating outfit. I had the knee-high socks, jogging shorts,
Nice.
shiny tights, and a giant cell phone.
Yes.
That's awesome.
Oh my god, that's great.
Only missing a headband. That's the
And
only
big
thing.
hair.
Maybe
Yeah, I was missing a headband. I had a wristband on. You can't see it. I did have a wristband.
Oh
on.
yeah, I see it. Pink on the side there. Yeah, I got
Pink
it now.
on the side. Yeah. I had big hair. I had blue eyeshadow. I was working it. Working it for the 80s.
That's right.
Yeah. Let's see. Yeah, so brainstorm ideas. We're gonna have like 7 hours
A day.
Days, so
a
14
day,
days.
and there's going to
14
be I think we can take breaks. We will be able to take breaks in between. But
Not
we
at the
will-
same
not at the same time. Someone always has to be manning the stage.
We can just pull random people onto the stage too, right? That are, like,
Absolutely. We can
walking
we can
by.
interview kids,
time.
parents, do like
Oh.
random
Oh my gosh.
interviews. It'll be so
This
fun.
is it. I'm doing the quiz show.
Oh, we could do a quiz
Great.
show. That would be
Yeah.
great.
Which of
Love
these actually, like cryptozoology, which of these creatures actually existed?
Right. That's
And
great.
then we have a fabulous prize we could bring up some of the kids to give the answers and then give them away fabulous prizes of undescribable value.
Do we have old t-shirts or anything that we would want to give away as prizes?
I mean, I can
Yeah, I'm
bring.
not
I
giving
can-
a
I
kid my
can
old
pack-
t-shirt. That's just weird.
No, that's not what I
know.
meant. I
Huh?
meant the older versions of the TWIS t-shirt. If we have, like the robot domination t-shirts. You have some of those lying around, right?
Yeah. Not a lot, but I
Not a
do.
lot.
Yeah.
Just-
I'll
it
have
might
to
be
look. I'll
nice to
see.
clear some
Mhm.
of that out.
What? This stuff is history, man.
Of course it is.
Highly
So you can keep
collectible.
a few, but I'm just saying you don't need, thin out the herd a little bit. Make space for new
Um,
t-shirts.
Yeah, so we have just our general our
old music
stage
CDs?
general stuff that we'll be doing for hours every day. And then we are also going to have a 20-minute stage slot on one of the official stages that's
Huh?
there. So we're going to have like a 20-minute show each day at this other stage, which will be
should-
like this opportunity to be like, hey, we're this week in science and do something. I mean, 20 minutes is such a small bite-sized thing, but
Sounds perfect for a quiz show.
Or we could each do one story.
But we always do that. We should go
Oh
and
my
do
God.
something totally different.
But
it's
the,
what our
the
Hey,
point
Hey,
of
how
the
long
main
does it take to
stage,
learn how to juggle?
Justin, the point of the main stage is to expose all of these people to the show that we offer.
yes.
So the
Yeah.
mini stage is perfect to do silly things we don't normally do.
Yeah, because we're just filling time and we're just being like,
Yeah.
look at our personalities. You're going to like us.
All right, ladies and gentlemen, we're just treading water here for 7 hours. Don't really have anything prepared, but
Hey, we did 21 hours.
any talents they want to come up on stage and do for the rest of the audience? Yeah, I know you'd be more comfortable if there was a dog up here, right?
Right. Exactly.
Identity 4. Thank you. Or Justin can just do one story.
Yes.
Let's see. Over on over on YouTube, Barry, I'm not even going to try and say what, I don't know. Barry over on YouTube says we should have a plasma globe on our stage. It might be a cool set decoration. It has a science feel to it, and people tend to notice it.
What if we just got a whole bunch of Erlenmeyer flasks?
Right? Then the mighty Chibunga says a plasma globe with a sign that says, "Please do not lick the plasma globe."
That's great.
Good job, you guys. That's funny. Oh, Joshua Tree, contact in the desert. I'm not going.
I'm thinking I might put, if you're open to it, Kiki,
What?
in the Zazzle store, hats, kind of in the style of the red hat with the white writing. We'll do a different color, probably orange with black writing. You know, that says "It's all in your head," and then it'll have the TWIS logo on the back.
One of those.
Yeah,
we should have an "It's all in your head" thing.
In fact, maybe I'll make it right now.
Wow.
We should have that. We should have it.
The future
right.
swag.
It's all in your head.
It remembers the sign in for the TWIS store, because if not, this is going to take me a minute. Oh, crap. No.
You're funny.
I think you emailed it to me, right?
I did.
I just have to find it now. My cookies have been cleared at some point.
Oh, I hate it when my cookies are cleared.
Yeah.
No, I clear my cookies all the time. You should clear your
often.
cookies all the time.
Because
websites don't need to leave their cookies on your browser. You don't need that.
Yeah, but I don't remember any of my passwords.
I don't think that has to do with cookies.
Isn't it?
Contact in the desert. Joshua Tree. That sounds like it would be fun. Speakers, conferences.
Oh my gosh.
Starry skies.
Ooh, I did it.
Super cosmic-y. That looks like fun. I'm not going though.
Yes, save that password. Thank you.
Save your password. Give yourself a more difficult one. Sign in for yourself. Make yourself a more difficult password.
All right. Let's see. I want
That's right.
Products.
Armando, Dr. AK on Twitter. He liked the Space Marines. Hashtag Space Marines. That's good. Ooh, I'm tired.
Okay. Let's see. How do I make a new thing?
How do I? I don't know how you do anything like that. Yes, the more bits long, the better. I got, what's one of those password programs that does all the password helping. I got a password helping program on my laptop. I just need to install it on this computer and connect the accounts so that everything is safe. Yes, LastPass. I think it's LastPass or something like that. Yes. And there's like a password generator. So if you want a password that's completely random that no one will ever figure out, it'll just give you one.
Cool.
Mm-hmm. Whiskey Renegade asking, is this going to be broadcast live to watch here, have a chat room? I do hope so. I don't know exactly how it's all going to work out. We're going to see what we can do. And
likely we won't know until the very last moment.
Yeah, because my problem.
To set it up.
Yeah, I don't know exactly what. I don't know exactly what our internet connectivity is going to be like, and if we'll be able to, I do know that the one camera that's made for streaming that I have that I can take because it's really small and wonderful. That it broadcasts to Facebook. Might also go out to Periscope as well, but I need to test these things. I need to get a phone that can work with it, an iPad or a phone that can work with it.
All right.
Yeah.
I think we've reached the end of our ability to continue rambling.
Yeah.
Uh-oh. It hasn't been 7 hours yet.
A mere 2.5 hours in. We wouldn't even be at the halfway point yet for day one of the big show.
That's true.
That's right. Not even the halfway point. 2.5 hours, easy. 7, we'll see. We'll see how it goes.
All right.
All right, you guys. If you have any advice for us, ideas for what we should do. Yeah, sleepy time now. Yes, identity 4. Meh.
Say goodnight, Justin.
Yeah, if anyone has ideas for what we should do in Philadelphia or on our hours of podcasting, streaming, etc., let us know. That'd be very helpful. And thank you for joining us tonight. Say goodnight, Justin. He's already good nighted.
Say goodnight, Kiki.
Good night, Kiki.
Good night, Spicer. Oh, spicy. Oh, look at the
Bye, Spicy.
Good night, Spicy.
Oh, why does he look nervous? Why does he always look nervous? He just looks flustered.
It's
Give me that
hereditary.
job. I won't look flustered.
Good night, Blair.
Good night.
All I brought was the electoral map again this week. I'm just going to show you all everybody the electoral map just so there's no confusion. Okay, first question. Okay, I'm going to hold up the electoral map in response to that question. Second question, over there, whatever your name is. I don't care. I'm just holding up the electoral map.
Right.
That's job security. That's how you do that job right there. Know who you're actually presenting to. Not the American public. You're presenting to the boss, the CEO of the Comfort Tree. Good night, everybody.
Good night.
Good night, everyone. We hope to see you again next week.